Hi. In order to factorize using the sum or difference of cubes, each value in each term must be a cube. If this is not the case, we cannot factorize using this technique. So what happens if we have an example like this? When we first looked at factorization, we said that the first thing we must look for is a common factor. So let's do this now. Here we have 3p cubed minus 24. 3 and 24 are both multiples of 3. So let's take out 3 as a common factor. And we can say 3, open our bracket. 3 divided by 3 is 1. So we get 1p cubed, which is simply p cubed. Negative 24 divided by 3 is negative 8. The aim here is to remove a common factor from both terms so we are left with 2 cubes. Here we have p cubed, and here we have 8. They are both cubes. So now we can factorize using the difference of cubes. So we can say 3 outside of our bracket. Open the first bracket. The cube root of p cubed is simply p. We have a negative sign. The cube root of 8 is 2. Let's close our bracket. Open our new bracket. Here we have p. Square it, and we get p squared. We have a negative sign, which means this will now be positive. 2 multiplied by p is 2p. Finally, we have negative 2. Square it, and we get positive 4. And we've now factorized this expression up here. Let's look at another example. Here, k has an exponent of 15. So how do we factorize this? In previous videos, we said that any variable with an even exponent is a square. That is because any even number is a multiple of 2. Based on this, we can see that every multiple of 3 is a cube. 15 is a multiple of 3, so k to the power of 15 is a cube. To find the cube root, we simply divide the exponent by 3. Let's do this now. Let's open our first bracket. 15 divided by 3 is 5. So the cube root is k to the power of 5. We have a minus sign. Put a minus in there. 125 cube root gives us 5. Let's close our bracket. Open our second bracket. Now we want to square k to the power of 5. To do this, we multiply 5 by 2 and we get 10. So we get k to the power of 10. There's a minus sign here. So the opposite sign is a plus sign. 5 multiplied by k to the power of 5 gives us 5k to the power of 5. Finally, we have negative 5 squared, which gives us positive 25. Let's close our bracket. Let's do one more example. 16a to the power of 7y minus 250ay to the power of 4. We don't have any cubes in this expression, so we have to take out numerous common factors. Here we have 16 and 250. Both are divisible by 2. So let's take 2 out as a common factor. Here we have a to the power of 7 and a to the power of 1. So we can take out a as a common factor. Here we have y and y to the 4. So y is a common factor. Now we can open our brackets. 16 divided by 2 is 8. A to the power of 7 divided by a is a to the power of 6. Y divided by y is 1. We don't have to write it down. Then it's our minus sign. 250 divided by 2 is 125. A divided by a is 1. And y to the power of 4 divided by y is y to the power of 3. Now we have 8. A to the power of 6, 125, and y to the power of 3. They are all cubes. So we can now factorize this bracket using the difference of cubes. Let's put our 2ay outside the brackets. Open our first bracket. The cube root of 8 is 2. 6 divided by 3 is 2. So the cube root of a to the power of 6 is a squared. We have a minus sign. The cube root of 125 is 5. And the cube root of y cubed is simply y. Let's close our bracket. Let's open our second bracket. Now we want to square 2a squared. 2 squared is 4. 2 multiplied by 2 is 4. So the square of a squared is a to the power of 4. We have a minus sign, so we're going to have a plus sign over here. 5 multiplied by 2 is 10, so we get 10a squared y. And finally, we want to square negative 5y, so we say positive 25y squared. And we have now factorized this expression. Please look at more examples like this in upcoming videos.